Hi, my name is Martin Langmaid, and in this video I'm just going to run through the Peplink product overview presentation and give you a bit of an introduction into Peplink, their products, technology, services, and why you might be interested by them. So let's get started. So who are Peplink? They were founded in 2006. They've got loads of patents around SD-WAN and VPN bonding, and particularly sort of traffic management and configuration management and system management. They've been doing this for a long time, right? And they've got some comprehensive wireless SD-WAN capabilities, which we'll look at shortly. It's a global brand. It's in use everywhere by every type of almost every type of imaginable kind of user type or company type, whether you're a bank, enterprise, government, even individuals in motorhomes. There's Peplink products just about everywhere doing what they do best, providing reliable connectivity. Peplink as a company are driven by a really small, passionate team. They're a small giant, right? They have 127 people in the team, yet they've got a global reach and they're doing amazing things. It's fantastic to see how successful they're being. But also from the perspective of end customers and partners, what it really means is that you don't have to go through tiers and tiers of people to get to the person you want to influence or speak to or get support from. And that's really, really useful and really powerful when it comes to support. And then there's this, generally speaking, an extension of that, this idea of direct communication. Engineers are on the forum, senior management are on the forum. You can reach and speak to and get support from everybody within the company very, very easily. Oops. So they've recently been recognized by Gartner. Was that last year? I think it was. And specifically they were included in the Magic Quadrant for WAN edge infrastructure. This is where Peplink have always been, right on the edge of the network, managing connectivity. And even more so now with this, with the concept of SD-WAN, right? And they're in there with all of the other SD-WAN players, of course. But really, the highlight for Peplink is this wireless SD-WAN capability, which we'll talk about shortly, I'm sure. So what's the driving force behind Peplink and behind the WAN management side of Peplink? It's all about unbreakable connectivity. Businesses today need to be connected to the internet to work, right? You know, it's not like it used to be. You used to have local mail servers and local file servers, and you could work even when there wasn't internet or when the internet was poor quality or low speed. Now, everything is cloud hosted, and so you need to have reliable connectivity. So when that goes down, you're in a mess. There's nothing you can do. So there's this idea of multiple lines, and that isn't a new idea. The idea of failing over between lines, and Peplink products do that very well. The kind of session-based failover. But when a WAN link fails, people are affected by that, right? You know, their sessions are torn down, they're broken, they're disconnected, and they have to restart a session on a new link. So there's quite a level of interruption when a WAN link fails. And the big idea behind Peplink SD-WAN is this concept of speed fusion, which is their proprietary technology, a VPN bonding technology that creates a single logical link using multiple WAN links. So even if a WAN link were to fail inside of a speed fusion tunnel, the users don't notice because their traffic is redirected at a packet level across the other available WAN links. It provides unbreakable, hyper-reliable connectivity. And it can also be a lot cheaper, right? You know, if you look at, particularly when we're thinking about bandwidth and reliable bandwidth, if you weren't using SD-WAN technologies, the only way to get really reliable bandwidth is to buy business grade, enterprise grade fiber connectivity that's dug into your building. And that fiber connectivity is expensive, right? With really good SLAs from the ISP, and maybe with some sort of DSL as a failover circuit perhaps, or even another fiber circuit as a failover. And what Peplink argues is that you don't need to get an MPLS circuit in place or a lease line in place. You can actually now combine multiple consumer or business grade connections to give you the reliability that you need, right? So mix and match not only fiber lines, DSLs, and cellular connectivity as different technologies, but then get those technologies from different providers as well. And when you combine all of those together, if a single operator fails, if a single technology fails, you're still connected. You've still got a reliable internet connection. You're still connected to your applications. And when you do it that way, when you buy lots of cheaper, smaller pipes, internet connections, and combine them, ultimately it becomes cheaper in the long run, rather than spending a fortune on private lines, which arguably aren't as reliable, because you're typically getting them from a single provider. Even when there's a mix of fiber and DSL, it's normally from a single operator. It's normally from BT or from Virgin or from Vodafone or whatever. And so you're paying more. You're not necessarily getting more bandwidth. You're not necessarily getting more reliability. This is the argument in general for SD-WAN, and specifically here for Peplink SD-WAN. And Peplink's done this for a decade now, or more now. I used to work for Plus, the one in the bottom right hand corner. I was their server and network architect back in the day, and that was us replacing a 37 site MPLS network that we outsourced, that somebody else provided and managed, and was cumbersome and expensive, and replacing that with business DSL circuits and back then 3G cellular connectivity as well. And we saved a fortune, hundreds of thousands of pounds a year, because we could manage it ourselves, respond to the business needs but faster, and use whatever connectivity was available, not just really expensive fiber or ridiculously expensive business or MPLS DSL, right? So SpeedFusion is the key thing. It's the SD-WAN technology. What is it? How does it work? It creates a single VPN, logical VPN tunnel between one or more, or two or more devices. So from one point to another, combining multiple WAN links at either end, effectively, right? So a single user session is split up, spread across all the available WAN links, and then put back together at the other end. And you can control how that works and the techniques applied to that traffic as it goes over the VPN. But fundamentally, it's about separating or virtualizing the user session away from the underlying connectivity. So to make SpeedFusion work, you need two SpeedFusion capable devices, and at least one of those devices has to be targetable. You have to be able to route traffic into that device. So if you're at home on a DSL circuit, it's a dynamic IP, which is fine, and typically you can route traffic into that. But if you're on a 4G LTE connection, you typically get a private IP, and you get carrier grade NAT, which stops the inbound traffic. So you need to keep these things in mind. But once you've got traffic talking to each other, and devices talking to each other and creating the VPN, you can do a full range of layouts there. You can have hub and spoke, which is the first one, where you might have a central data center and all of your remote sites hanging off of it. You can do that star mesh, which is the idea of particularly for VoIP scenarios, where you might have a central location but then let the remote sites talk directly to each other to let VoIP go site to site to lower latency, or any other real-time traffic for that matter. And then you can do a full mesh where every site can talk to every other site if you like. That gives you super reliability, right? Multiple paths to get your data from point A to point C via point B. And you can manage this and control it and configure this stuff in lots of different ways. You can do it directly on the devices in a typical way, sort of with a web admin interface. You can manage it with InControl 2, which is a cloud management platform. And if you do that, then you can get zero-touch capability. So send a device to a remote location, they take it out of the box, turn it on, plug it into an internet connection, and you can then push down a full config and get it all working completely remotely without ever seeing or touching the device. So how does it work? What we're doing here is we're taking sessions from a site, we're encrypting those, breaking down to packets, and then they're being sent over those fiber lines on the right back to site A, where the packets are received over multiple links and then put back together again. So that transmission of those packets is done at the line speed of the lines, of course. So you get a combination of the available bandwidth across the links, but there's a little bit of an overhead. I generally say 20%. It's a bit less than that in practice, but you lose some bandwidth because of the additional headers that have to be added and because of the processing overhead too. So here are the core technologies. The very base layer is PepVPN. That is IPsec VPN with a management capability put on top of it. It's very clever. Even if you're just doing point-to-point VPN with a single WAN at both ends, there's a benefit to using PepVPN is that it's easy to set up and it's easy to manage, and it copes very well with IPs changing and with WAN links changing, that type of thing. Great reliability capability. Then there's this idea of hot failover. So that's when you've got a single unit, you've got two lines into that unit, maybe dual cellular or DSL cellular, and you've created a hot failover session over the top of that, SpeedFusion session. So you only use one of those WAN links at a time, but if that were to fail, it automatically fails over to the other link and at a packet level, so the sessions stay up and users don't notice, right? Really, really useful. Then on top of this idea of multiple WAN links and packets being distributed, we've got technology. So WAN smoothing is one, and then forward error correction, which is now available, as another, where those packets that are coming from the device, the traffic that's coming from whatever it might be, either from the cloud down to your computer or from your computer up to the cloud, those packets have technologies applied to them. So WAN smoothing is about duplicating your traffic over multiple WAN links, so that if a WAN link fails, or if there's packet loss, or if there's jitter, then or if the line is just poor quality in any way, it doesn't matter, because you've also sending your traffic over another link, and whichever traffic arrives first at the remote site is the one that's accepted. Forward error correction is when we add parity information to the stream, so if any data gets lost along the way, it can get rebuilt in real time at the remote end. And of course, when you've got multiple links, you can also do bandwidth bonding on top of those, where you can aggregate bandwidth across multiple links. I tend to find that we're less worried about bandwidth nowadays, and we're more worried about reliability. So for me, SpeedFusion is about reliability first, bandwidth bonding second. We mentioned right back at the beginning that Peplink, one of their specialisms is wireless SD-WAN, and that's certainly the case. That's what they've got a whole product range called the Max Mobile family, right? Which is a series of routers designed to work with Wi-Fi and cellular WAN connections. So each modem, cellular modem in these devices, has got redundant SIM slots, normally dual SIM slots per modem. Now that lets you do things like send out a single cellular device with multiple SIMs installed, so that if you're not sure where it's going to be deployed, you can try with one operator and then fail over to another operator. Or you might have a SIM that's only got 10 gig of data this month, and you've got another SIM from the same provider with 10 gig of data, so you can fail over between SIMs. Or it might be down to the way that the operator caps you when you do a certain amount of bandwidth, or maybe you have a local SIM, and then this router is installed in a bus, and the bus travels to a different country, and you want to fail over to the local in-country SIM when it arrives in France or wherever it might be going. So SIM failover is key. And then you've got In Control 2, which manages and monitors all of this and lets you see where the Macs devices are if they've got GPS enabled, and also manage SIMs and manage the devices very easily over their cellular links. And there are Macs devices with IP67 enclosures for kind of really rugged installs on oil rigs or in boats. And the key thing here is that even though we're using wireless technologies for the WAN, we're still capable or able to use the SD-WAN, the Speed Fusion bonding technologies over the top. So you can deploy an HD4, which has got 4 cellular connections anywhere you like, multiple SIM cards, combine all the bandwidth, get improved upload and download bandwidth, but also get super reliability. And you can take Unbreakable VPN technology wherever you need to go. So the Macs mobile family is split into a number of groups. The first group is the USB focus group. These are some of the earlier products where a lot of cellular connections were USB dongles primarily, and so you can buy devices that you plug USB dongles into with their SIM cards in to get connectivity. Then there's transportation focused products. They tend to be relatively small. Normally it's 2 or more LTE connections, and it's about providing content on the go. It's about ignition sensing, that type of thing really. And then we've got the business ready product range. So the BR, and one of the most popular devices is the BR1. It's a single cellular dual SIM device, very rugged. There's a whole range of BR models that enable you to do things like power them by USB, have very small ones. You can do RS-232 serial interfaces to monitor weather stations, for example. There are weatherproof versions to go on the side of boats and in weather challenging situations, right? There's a whole family there. So if you're interested in just getting an internet connection somewhere to do something, then the BR range is a good one to look at. And then we also have the HD series, the heavy duty series, and the HD series is much more focused around more throughput, more cellular connections, and it's more connectivity really, and managing that. So that's the wireless SD-WAN devices. There's also the wired SD-WAN devices, which Peplink call the Balance product range. And the Balance name really came from the early days where it was all about load balancing, right? Multiple WAN links where you could do outbound load balancing, but also inbound load balancing too. And that capability is still there in these devices. Some of the smaller ones don't do inbound load balancing, but that capability to manage multiple WANs is certainly the kind of key technology, underlying technology in this whole range. They're really easy to set up. They're very easy to use. You can do some really great outbound policy rules and manage how the WAN links are used, in what order, at what time of the day. They're really rugged devices, enterprise grade, lovely bits of kit. And just like before, full zero touch capable, In Control 2 managed. So you can deploy one of those, you can send a replacement device, completely configure it on the fly when it arrives at site. And there's a number of groups of these too. We've got the power user, home user group. So Balance 1, Balance 2030. We've got the branch office locations, the Balance 210, the 305. This is larger rack mounted devices now we're talking about, rather than the desktop mounted ones from the home user group. Then we've got the larger office, so more connectivity, more users, more throughput required. And finally, we've got the really big offices, or the data center locations, where you need a really big chunky balance to cope with throughput, number of sessions, multiple WAN links. And then to complement both the Max and the Balance product range, there's a series of access points as well. Everything from Dinky, the AP1 Mini, which is one of the smallest APs that you'll see probably, right through to IP67 grade, mount outside and forget, outdoor capable APs as well. All of the APs are centrally managed in Control 2 again, and all of the APs can be zero touch too. And then in the same grouping as the APs, we've got this device connector, and the device connector is really, it's a Wi-Fi bridge, right? Transparently connect from an existing wireless network or one that you're building with the other APs and provide a wired interface into that Wi-Fi network. What's nice is that the device connectors with the dual radios can also do speed fusion over dual Wi-Fi as well, something to keep in mind. So you can combine the 2.4 and 5 gig wireless networks with speed fusion to give you real reliability. So picture as the docks or a bus depot, and you've got 2.4 and 5 gig Wi-Fi access points deployed around those locations, and you've got vehicles driving around inside, and you need to give a wide Ethernet connection to something important in that vehicle. Maybe it's video streaming, maybe it's some sort of job ticketing system. You can do that with the device connectors and create that super reliable link between that goes over both frequencies at the same time. And then we've got the Surf SOHO. This is separated out from the rest because it's a little bit different. It sits in a middle ground between the home user and the enterprise user in some ways. It's really taken off as a device because there's been a lot of publicity about it in the security forums. A couple of key voices there have enjoyed the Surf SOHO and how well the software's written and its capabilities and how secure it is. So we see SOHOs deployed at homes, in motorhomes, all over the place. Again, in Control 2 managed, and lots of WAN connectivity options there. The cellular, USB cellular, Wi-Fi WAN, that type of thing. And then finally, there's a virtual appliance, the FusionHub. You can install the FusionHub on just about any platform, hosting platform that's out there, VMware, Hyper-V, and public kind of virtualization platforms too. You can deploy anywhere really fast. It's a tiny image. It's like the OS is about 15 meg. I think the actual raw disk image is about 400 meg. But you can spin it up in literally minutes and get a SpeedFusion VPN connection into a data center wherever you need it to be. It does some good stuff, some split tunneling, so you can do you can tunnel all traffic or some traffic up via the FusionHub. You can tunnel between FusionHubs. You can have FusionHubs in different data centers and different providers and create a secure SD-WAN like that. It just gives you a bunch of new capabilities because it's virtual and because it's easy to deploy and manage. And one of the key things here is that if, as we mentioned earlier, if you want to use SpeedFusion, you need 2 SpeedFusion enabled devices. Well, you can buy a small device for your home office, for your home use to put in your vehicle, and you can then host FusionHub in the cloud for free. There's a free license to FusionHub Solo, so you're just paying for the hosting cost, not the license itself. And you can create a SpeedFusion VPN between your device and the cloud. This is perfect for people that want to, let's say, buy an HD4 with 4 cellular connections and do video streaming, right? They can host FusionHub in the cloud, stream video to it, job done. It's recently changed from having a 100 megabit limitation on the throughput to completely unlimited now. And if you've got a multi-WAN Peplink device and you're using multi-WAN, you really should be using FusionHub. Have a play, see what you can do. Finally, we've got the PepSIM range of products from Peplink. Now, this is the IoT product range, and this slide isn't showing very well, but let's see what happens. Obviously, Gartner has said that, and everybody is saying that IoT is going to be massive. There's going to be billions of devices, and what we really want to do, or want to see Peplink doing rather, is that taking all the lessons they've learned from In Control 2 and the power of In Control 2 and centralized management and apply it to IoT devices. And there's a bunch of PepSIM devices that exist right now. things like the smart reader, which is about time and attendance and access control. There's GPS trackers, there's digital signage, there's this a really interesting range of products, which is software-defined power unit, which was really designed for transportation originally. It was about recognizing that you've got multiple batteries, that you've got weird power sources on vehicles, and it cleans up those power sources, but lets you monitor those, the power and the quality of the power, the voltages and the current and the power draw, all centrally in the PepSIM control panel, which is nice. Yeah, so a range of IoT based products, more are coming for sure, and it's nice to see Peplink keeping an eye on the IoT world and seeing what they can do there. So as well as the physical products, we've talked about FusionHub as a virtual appliance, and I've mentioned InControl 2 a number of times. That deserves its own video, to be honest, which I'll get around to doing. There are a bunch of virtual appliances and also warranty and services that you can buy from Peplink. InControl 2, there's a public version that you can use and you can buy subscriptions for, or you can actually host your own InControl 2. So banks and health authorities and people that need tight control over their networks will often, like the military, will host their own InControl 2 internally if they want, or because they need to. And then we've got support and warranty and subscriptions and stuff also available too, of course. And there we have it. That's Peplink in a nutshell. I hope you found that interesting and useful. Yeah, I'm going to do a bunch of these videos and give you a bit more depth into Peplink and the products. Look forward to the next time. Thanks very much.